Hey guys, how's everything going? This is JSer. In this video, I'm going to try to solve 300 longest increasing subsequence. Actually, I've done the similar question is which is longest continuous increasing subsequence, and it could be easily solved. For this new problem, we're not asked to return the continuous increasing subsequence. Let's see if there's an example like this. We can pick any number in order of left to right. So the longest should be 2, 3, 7, 101. So the longest should be 4. Return the length of longest one. There might be more than one LI's combination, only necessary to return the length. My algorithm should return in quadratic complexity. Well, let's see how should we solve it. Let's take the example like this. We're going to find the longest increasing subsequence. Let's see if there is optimal result. This is how I think of these kind of problems. Suppose there is an optimal longest string, like suppose optimal subsequence, subarray. Let's see if the last one is in it or not. If 18 is in it, then it must be the previous, what the previous one is. It must be some numbers, right? And yeah, so say the LSI equals the length which ends at index I. No, which equals the length which length I is what we want to get. Okay, this is the SI, and this NI is the longest increasing subarray which n, right, at I. So well, of course, this NI, if last one is only one, then previous one must be one of these, right? So it should be math it should be max, right? Max of what? Max of max of list and I and j 0 to I minus 1, right? So the previous one might be here. So it should be this plus 1. And there's a condition set if it is bigger than it, right? If this one is bigger than it. So if nums I is bigger than nums j. So for all the other cases, well, it's impossible. So infinity. So this is the case, list in I. Well, what we want to get is the list I. We don't need to end at I. So of course it should be max list and I equals 0 to standard. Right? Pretty clear. So actually we need to we need to calculate the longest increasing subsequence which ends at specific index. Well, to get the 18, we need to get each of 10, 9, 12. So it becomes the recursive, and we actually need to calculate the list n from left to right, right? So let's do it. So the result, let's set this result equals infinity. And we use create LIN. Okay, LIN at n at equals new array num.n field 0. Cool. So now equals 0 as with the num.n plus. And yeah, this end at this end at the minimum should be the maximum itself. Of course, itself is of course valid increasing subsequence. So let's just how should we do it? We will for as we did here. We will list okay the max of previous ones, right? This could be we get with a map. So list end at equals I equals max. And the first it's itself. So it equals 1 itself, and all the other it should be nums slides start from 0 and to n minus 1 I minus 1, and these will map. This is not nums, it should be the least n at slice and then map, which is the item. And we will return if nums I if nums I is bigger than nums this is the j. Okay. If it's bigger than j, then should be item plus 1, if not minus infinity. So now we set it, and yeah, and then we update the result. Okay, we can update while we are looking through it. So if okay, result equals max I max result, and then we could return the result. Okay, we're done. Let's try to review our code before we submit. Initialize the result. We use array to keep the longest increasing subsequence, which ends at a specific index. To get it, we need to loop through 0 to I minus 1, the previous one, slice it, and for each item, if it is smaller than the new end item will be is bigger, then we plus 1. If not, it's minus negative infinity, right? And then we get the max. Of course, the itself is a valid increasing subsequence, so this will be the right. And then we update it to the max. So I think it should work. No, we are getting it wrong. I is here. Let's log the this end. We get 1 1 1 1. This is 1. This should be 2. Why? slice 0 minus 1, would be some problems? Uh-oh. Yeah, there's a problem. I'm sorry. If that's the case, actually, we should initialize with 1 and start with 1. This is good. Ah, I'm sorry. Slice, it should be I. Shit. Great. Sorry. Longest. I don't need to minus in negative infinity. I could just use 0. Stupid. If it's only 1 0, we didn't update it. Oh, shit. The results should be 1. Ugh. Yeah, because we start with 1. If there's only 1 item, this is not updated. Stupid. Oh. If it's empty, we got 1. Ah, sad. Okay. Nums analysis. If it's empty, just return it empty. Cool. We're accepted, but not that fast. Well, the time and space complexity is. Let's see. For time, for each item, we actually use 2 for loops to get it. And yeah, that's what we want. It's contracted time, space. Well, we use this array to cache the length in the edge index, so it's linear time, linear space. So this is it. And we're asked to improve this improve the approach to big O nlogn time complexity. Let's see if we can do it. So okay, copy the code. So how could we improve it? To improve, we also need to analyze the result, the example here. Okay, so first, well, if we are going to get the longest substring, let's see for this specific example. First, for 10, nothing, right? So it's 10, and then we get 9. Because line is smaller than 10, then it should be 9, right? So because if there's a substring longer with a 10 in it, then 9 could be used, right? 9 is more than 10, yeah. So if we replace 10 with 9, we will have more possibilities. So it's 9. The same is for 2. And now the next one, 5 is bigger than 2, so this is a 2. The maximum will be 2. And then we met 3 as the same. If there is a subsequence, the following subsequence which bigger than 5, then if we replace 5 with 3, it will help us, right? So now we have 3. Again, we have 7, 101. Now we have 18. It's the same. 18 is more than 101. So if switch to 18, it will have more possibilities. Now, what if there is called a 4? What should we do? Well, and 4 like 19. What should we do? For 4, this might be a new longest substring, right? 2, 3, 4 might be a new one. So if we pick that up to 2, 3, 4, and then this is it, right? So this is the previous one, and for 18, now we'll get 2, 3, 4. Now we're getting 19. So of course 2, 3, 7, 18, 19 should be used, right? But where should we put it? Well, where should we put 19? How should we know that we should use 2, 3, 7, 18, 19? 2, 3, 4. Here is 2, 3, 4. If we had 19, we have 4, but we have 2, 3, 7, 18, 19. And if there is possible again, it's 5, 6, 7. Of course, this should be 5, 6, 7, right? This, if again there's 8, then it should be the new longest increasing subsequence. So the core problem is for 19, how should we know it's this? How should we do it? Well, we could see that actually we have seen that the shorter optimal subarray will have a smaller ending, right? Let's see, for 19 we have 2, 3, 4. But we also have 2, 3, 7, 18. Of course, and we have 2, 3, and then we have 2, right? Where should we put it? You see, for shorter numbers, shorter subsequence, it should have smaller ending, 2, 3, 4, 18. Why? Why? Because it's bigger. Then this bigger number could be used at this longest, right? So it would become bigger. So the shorter, the smaller ending. Now you're adding new 19. We actually could compare this new 19 with the ending. So we actually have, this is the maximum, right? This is the maximum subscript we can get now before we add 19. Now we will see where should we put this 19. If it is bigger than 18, well, it put here, so it will become 2, 3, 7, 18, 19, right? Cool. Now if we're going to get 5, we need the longest one, but with the numbers smaller than 5. While we're comparing to the ending item, well, it should be suitable for here, right? So it's got 5. And then we got 6 through 3, 4, 5. And then because this 18, 5, this could be removed, right? Yeah. Wait a minute. We got 5. So for 3, yeah, this 4 is smallest. So we got update 5. And this is it. No. A 5. Oh no, there's no need to update 5. Yeah. Because it's 18, it should be put here. It should be put here. And this should be updated. Right? Yeah. And then we got 6. Well, 6 should be put here. Well, this should be updated, right? If there is a bigger number than 19, it might be bigger than 6 also. So we have this. And then we have 7. Of course, we have 7 like this. Now, go back to if we have like a 1, 2, 10, 5. Okay, 2, 11, 5. What should we do? We have 2. This is the longest one. And then for 10, 2, 10, right? 11, 2, 10, 11. Now we get 5. Well, we get 5, and it should be between here, so it's actually be put here, right? But this actually is the same to the next one, then at then. So actually here should be updated to 5. Something like this, right? So for each number, if we're comparing to the ordered ending item, it will actually use logn to the binary search, and then we update the array, and not the array but ending item only. And for each item, it will cost us logn times totally for n items, so n log n. So we should use, so what? We should store user array to hold ending item at optimal sub array with length I. All right, cool. Let's use that. That's ending. Use array. Ending 0. It should be 0. There's no 0. Okay. Okay, for the first item, it should be for the 0. Wait a minute. With the length. So length is 0. It's not. So the 0, we just do 0. We start with 1. With length 1, it should be nums 0. Right? This is the ending at length 1. Okay. So now we 4. Now for let should get index or num. Num for that num of nums. We binary search the right length, right? Right optimal length. Cool, which is to actually binary search the insert position. Yeah. Cool. Now we're going to do binary search. Let start equals we search at 1. Right, start with 1. Let n should be, well, the ending then yeah. start 1 and start ending at length. Cool. So while start is smaller or equal to n, we get the middle. If num's middle is equal to it, if equal to it, then nothing happens, right? If it's equal to it, actually we could remove it. We're getting increasing. So if num, the middle one is our num, then we just continue. We should set a label. This is num loop. Continue num loop. Cool. And then if it's not, if num's middle is bigger than num, like here, middle is math 4, yeah, 4. Suppose you see this one, the target is smaller than it, then we should move the end, right? So end equals middle minus 1. The other case, start plus start equals to middle plus 1. So when there's last element like I start and both set to 5, but such 4, so we move the end to 4 to the position here, right? And if it is bigger than it, then start will move the next one. So actually we should return the start. Yeah, we should return the start. So the start index is what we want. Start is the position we should is the insertion position. Okay, inserting position. It might be 0. We start from 1. It could not be 0. It might be 1. Okay. So this is the length actually. This is the length. Start means the length, right? We've got 6 here, then the next one should be the length. 4 here, we've got 6, then yeah, length. And if it is 4, then it should be the previous one, right? So it should be start. Wait a minute. Okay, we previous one, but we need to append it, so it's still start, right? If it's bigger than it, then we append it. It should be next one, so it should be start. The length means the length of the optimal. Okay, and yeah, so let's see. We need to update it. If it is bigger than it, it's like nothing is there. We just set it, right? If okay, rename it. The length start is okay. Allow me to rename it. So the length of optimal sub-array equals start. If it is not set it means the longest one. So if endings length of optimal subarray is undefined, we set it, right? Endings set to start. Oh, not start, but nums. Nums. If not, we just we set 4 here or 5 or 6 here. It might be bigger than it or smaller than it. We need to choose the smaller ones, right? So we set it with length of optimal subarray. Set it to math name with length of optimal subarray. Oh no, should be no. Cool. So we are done. I'm not sure whether I'm getting this right actually. Let's try. Return. Finally, we return what? Return the length, right? That's 1. So we're getting the longest one. So this is the core we need to understand. Yeah. So we're putting, say, like if we're keeping like so what's the longest increasing subsequence sequence at length 1, and then at length 2, then add length 3. And if we do this, we know that the last item will be increasing, right? Because if it is smaller, then this could be moved here to create a bigger one. Yeah. So let's try. I'm not sure. Yeah, of course it's not right. Okay, let's do some debugging. Okay, we lock the endings. Let's see what we have. We got 0, 2, and empty item, and 10. Huh? There is something wrong. Why we have empty item? Interesting. We search the right index, which is a star. Okay, allow me to lock the endings. First we have 0, 10, right? And then, I see. So actually I made a mistake. You should start from the second number, right? For let I equals 2, I smaller than nums dot length, I plus plus. Const num equals nums I. The first one is already used. Okay, 1. The first one is already used, so we start from 9. Okay, so first we got 0, 2. Huh? What the? For 0 of I, num endings. We not get num 2. Where's 9? Where is 9? We continue. If we found it, middle. Ah, shit. I'm sorry. It should not be nums middle. It should be endings middle is the num. Ugh. Yeah. Ugh. Okay. This looks better. So we get 9. We update to 0, 9. Cool. And 2. So it can be a 0, 2. Right? Cool. So this for length 1, it should be 2. Now we get 5. We should get 2 is okay. And something wrong. The start actually should be, what we get the start. We're getting the getting start for no start. It's 1, 2, 1. For 5, it's 3. No, it should not be 3. It should not be 3. This is the nen. Yes, it is. It is 3 actually. Start. This is 0. This is 1. So if it is bigger, then start equals to middle plus 1. Okay, here, if one item is 2, so we actually search for 1, 1. Start. This next one should be 3. Yeah, the start actually is 3. But I know what happened. The start is the index of the endings. It's based on 0. But when we are updating, we should update it by, this is index. Okay, start insertion position index should be subtracted 1. Yeah, God. Okay, 1. We should update it. We're getting the number 5, and the starting index is 3. 0, 1, 2. It should not be 3. It should be 2. Where did it? And I'm sorry. Here should be -1. Sad. Yeah, sad as a dog. Cool. Now maybe this should work. Wow, it is working. Cool. I made a mistake, so the index here is 1, but actually it's endings length -1. So this is it. And yeah, the time and space complexity for here, the time, nlogn as we analyzed. For space would be is array here, right? So it's linear. Cool. Okay, that's all for this problem. Hope it helps. See you next time. Bye bye.